In this video, I'm going to show you how to complete the square on quadratic expressions. Completing the square is a process which converts a quadratic expression to a perfect square plus or minus some constant. Let's do an example. This first example is going to be straightforward because this expression already is a perfect square. To figure out what perfect square it is, we need to write it in the form x squared plus 2 times something x plus that same something squared. To see what we should fill in the box, we look to the x coefficient, 6, and divide it by 2. 6 divided by 2 is 3, so we're going to fill in 3 in the boxes. Now, this expression is the same as this one, just rewritten a little bit differently to reveal these 3's here. Now we can factor this expression, and we've got x plus 3 squared. There's our perfect square, and we didn't need any constant at the end. Now let's do a trickier example, which involves the use of a constant. So here's an example which is not a perfect square, and we're going to need to use a constant in it. But first we're just going to treat it like the perfect square in the previous example. We're going to write this 8x as 2 times something x. Well, 8 divided by 2 is 4, so we'll write 4x. And then we'll put a 4 here, 4 squared, so that way this whole expression will factor to quantity x plus 4 squared. But there's one issue, and that is 4 squared is not 10, that's 16. So we have to subtract a little bit, some other number, so that 4 squared minus whatever number we subtract makes 10, because we don't want to change our original expression. So 4 squared is 16, so to get down to 10, we need to subtract 6. And we're going to carry that down, and that's going to be our constant. So this expression equivalent to x plus 4 squared minus 6. Perfect square plus or minus a constant. Let's do another example. This example is a bit trickier still because we've got a minus sign, and we're also going to run into fractions. But the process for completing the square here is still the same. We just carry down the minus sign to form a perfect square x minus something squared, and to get into that format we have to rearrange this equation into this expression with a minus sign. So we still just have to ask 5 divided by 2, what does that make? That's 5 over 2, so we put that in the box, 5 over 2, and we can't simplify the fraction at all, so we're just going to have to deal with it. Our perfect square becomes x minus 5 over 2 squared, and the last thing is that, again, 5 over 2 squared is not equivalent to our constant. We have to add or subtract some amount. Right now, 5 over 2, that's equal to 25 over 4, and then our constant 7, that's equal to 28 over 4. So what do we have to add or subtract to get from here to here? Well, we have to add 3 over 4. And then we just bring down that plus 3 over 4 plus 3 over 4, and there's our perfect square plus or minus a constant. And that's it, we're done. One last example. This last example is the most difficult one because we've got everything kind of disorganized. We don't have the terms in order. Our x squared isn't first, and also we've got a negative on the x squared. So how do we deal with this? Well, the first step is just to rearrange to get the terms in order. We want the x squared first, so let's put negative x squared, then plus 3x, then minus 1. And now we can deal with the negative on the x squared. We just need to factor out a negative from the entire expression. So negative x squared minus 3x and plus 1. And now what's inside of the parentheses, we can do completing the square on that. So let's set up our completing the square template. It's going to be x squared minus 2 times something x plus that same something squared, and then we'll leave a little bit of room because we're going to add or subtract the appropriate amount to get down to 1. So to figure out what we put in the boxes, well, we do 3 divided by 2. That's 3 over 2. We put that in the boxes. And then 3 over 2 squared, that's 9 over 4. And 1 is just 4 over 4. So to get from 9 over 4 to 4 over 4, we have to subtract 5 over 4 at the end. And now we can complete the square. Within these brackets here, we can do negative of x minus our number 3 over 2 squared, and bring down our minus 5 over 4. And then lastly, we can just distribute the negative sign across both terms again. So negative x minus 3 over 2 squared, and then this time plus 5 over 4 because we're multiplying by negative 1. And there we have it. There's the perfect square plus or minus some constant corresponding to that expression. Completing the square is a pretty handy technique. In the future, we'll learn how to use it to solve quadratic equations.